on Chapter 3 about measures of variation. My name is Timbang and my partner is Rufino. So let's proceed.
The first topic in this chapter is range, or simply denoted with a capital R. Range. The range is the simplest of the three measures and is defined now. The range is the highest value minus the lowest value. The symbol R is used for the range. This is the formula. Let's try this example, which is the comparison of outdoor paint. Find the ranges for the paints in this example. These are the illustration of the outdoor paint or the variation of paint in months. In brand A, we see here that the highest value is 60 and the lowest value is 10. In brand B, we see here that the highest value is 45 and the lowest value is 25. This is the table from brand A and brand B. For brand A, the data values are 10, 60, 50, 30, 40, and 20. In brand B, the data values are 35, 45, 30, 35, 40, and 25. Solution. For brand A, the range is: first, the highest value is equal to 60 and the lowest value is equal to 10. R is equal to 60 minus 10 is equal to 50 months. For brand B, the range is, again, highest value is equal to 45 and lowest value is equal to 25. R is equal to 45 minus 25, which is equal to 20 months. Make sure the range is given as a single number. The range for brand A shows that the 50 months separate the largest data value from the smallest data value. For brand B, 20 months separate the largest data value from the smallest data value, which is less than one-half of brand range. Another example, employee salary. The salaries for the staff of the XYZ Manufacturing Corporation are shown here. Find the range. In this example, one extremely high or one extremely low data value can affect the range, markedly as shown in this example. This is the table. The staff and the salary. Number 1, the staff, which is the owner, the salary is equal to $100,000. The manager is equal to the salary of $40,000. Sales representative, the salary is equal to $30,000, and the workers' salaries are $25,000, $15,000, and $18,000. Solution. The range is: the highest value of the employee salary is equal to $100,000 and the lowest value is equal to $15,000. Again, range is equal to highest value minus lowest value. In this example, range is equal to $100,000 minus $15,000 which is equal to $85,000, and the range is $85,000. Another example. Problem. You take 7 statistics tests over the course of a semester. You score 94, 88, 73, 84, 91, 87, and 89. What is the range of your scores? These are the steps and solution. In step 1, sort the numbers in order from smallest to largest. 73, 79, 84, 87, 88, 91, and 94. Step 2. Subtract the smallest number in the set from the largest number in the set. The highest value is equal to 60 and the lowest value is equal to 10. The range is equal to 94 minus 73 is equal to 21, and the range is 21. That's all for the topic range.
Population variance and standard deviation. So before we start, let us define variance and standard deviation. Variance is the average of the squared differences from the mean, while the standard deviation is a measure of how spread out numbers are. Its symbol is the Greek letters sigma. So next, rounding rule for the standard deviation. The rounding rule for the standard deviation is the same as that for the mean. The final answer should be rounded to one more decimal place than that of the original data. An example. Find the variance and standard deviation for the data set for brand A paint. The data are 10, 60, 50, 30, 40, and 20. So let's try to solve this. So there's a step-by-step solution. So step 1. Find the mean for the data. We will use the formula for the mean, which is m is equals to summation of x over n, where n is the total number of values in the population. So the summation of x are 10 plus 60 plus 50 plus 30 plus 40 and plus 20 all over n, which is 6. So is equals to 210 over 6. 210 divided by 6 is equals to 35. The next step is subtract the mean from each data value. 10 minus 35 is equals to negative 25. 60 minus 35 is equals to positive 25. Then 50 minus 35 is equals to 15. 30 minus 35 is equals to negative 5. Then 40 minus 35 is equals to 5. And 20 minus 35 is equals to negative 15. The next step is square each result. Negative 25 squared is equals to 625. 25 squared is equals to 625. Positive 15 squared is equals to 225. Negative 5 squared is equals to 25. And positive 5 squared is equals to 25. And negative 15 squared is equals to 225. Then, let's find the sum of the squares. 625 plus 625 plus 225 plus 25 plus 25 plus 225 is equals to 1,750. Then, divide the sum by n to get the variance. Then the last step, take the square root of the variance to get the standard deviation. Hence, the standard deviation equals square root of 291.7 or 17.1. So it's more helpful to make a table. So in making the table, there's 3 columns, which is A, B, and C. Column A contains the raw data X, and column B contains the differences X minus the mean obtained in the step 2. Then column C contains the squares of the differences obtained in step 3. The preceding computational procedure reveals several things. First, the square root of the variance gives the standard deviation, and vice versa, squaring the standard deviation gives the variance. Second, the variance is actually the average of the square of the distance that each value is from the mean. Therefore, if the values are near the mean, the variance will be small. In contrast, if the values are far from the mean, the variance will be large. You might wonder why the squared distances are used instead of the actual distances. One reason is that the sum of the distances will always be 0. To verify this result, for a specific case, add the values in column B of the table on the given example. When each value is squared, the negative signs are eliminated. Then finally, why is it necessary to take the square root? The reason is that since the distances were squared, the units of the resultant numbers are the squares of the units of the original raw data. Finding the square root of the variance puts the standard deviation in the same units as the raw data. When you are finding the square root, always use its positive or principal value, since the variance and standard deviation of a dataset can never be negative. The variance is the average of the squares of the distance each value is from the mean. The symbol for the population variance is sigma squared. The formula for the population variance is sigma squared is equals to the summation of quantity x minus m quantity squared over n, where x is the individual value and m or mu is the population mean and n is equals to population size. The standard deviation is the square root of the variance. The symbol for the population standard deviation is sigma. The corresponding formula for it is sigma is equals to square root of sigma squared is equals to square root of summation of quantity x minus mu or mean quantity squared over n. So let's give another example. Find the variance and standard deviation for brand P paint data. The months were 35, 45, 30, 35, 40, 25.
So let's follow this step-by-step solution. First, let's find the mean. Where mean is equals to summation of x over n. Then it's equals to 35 plus 45 plus 30 plus 35 plus 40 plus 25 over 6 is equals to 210 over 6. Then the answer is 35. Then subtract the mean, which is 35, from each value and place the result in column B of the table. The next step, square each result and place the squares in column C of the table. As you can see on the screen, the tables are on the column C, the answers are already on it. So step 4, find the sum of the squares in column C. Summation of quantity x minus m quantity squared is equals to 0 plus 100 plus 25 plus 0 plus 25 plus 100 is equals to 250. Then step 5, divide the sum by n to get the variance. So sigma squared is equals to summation of quantity x minus m quantity squared over n is equals to 250 over 6. Then the variance is 41.7. Then step 6, take the square root to get the standard deviation. Sigma is equals to square root of summation of quantity x minus m quantity squared over n is equals to square root of the variance, which is 41.7. Then the answer is 6.5. Hence, the standard deviation is 6.5. Since the standard deviation of brand A is 17.1 and the standard deviation of brand B is 6.5, the data are more variable for brand A. In summary, when the means are equal, the larger the variance or standard deviation is, the more the variable data are.
The next topic is the sample variance and standard deviation. The formula for the sample variance, denoted by S squared, is, this is the formula, wherein the x bar is the sample mean and the n is the sample size. To find the standard deviation of a sample, we must take the square root of the sample variance, which was found by using the preceding formula. The standard deviation of a sample, denoted by S, is, wherein x is equal to the individual value, x bar is the equal sample mean, and S is the sample size. The shortcut formulas for computing the variance and the standard deviation are presented next and will be used in the remainder of the chapter and in the exercises. These formulas are mathematically equivalent to the preceding formulas and do not involve using the mean. They save time when repeated subtracting and squaring occur in the original formulas. They are also more accurate when the mean has been rounded. The shortcut formulas for computing the variance and the standard deviation for data obtained from samples are as follows. These are the shortcut formulas for variance and standard deviation. For variance, this is the shortcut formula. And for standard deviation, this is the shortcut formula. Note that sum of x squared is not the same as the quantity sum of x squared. The notation sum of x squared means to square the values first, then sum, while the quantity of sum of x squared means to sum the values first, then square the sum. Example: European autosave. In this example, explain how to use the shortcut formula. Find the sample variance and standard deviation for the amount of European autosaves for a sample of 6 years shown. The data are in millions of dollars. The data are 11.2, 11.9, 12.0, 12.8, 13.4, and 14.3. These are the steps and solution of this example. Step 1. Find the sum of the values, which is equal to 11.2 plus 11.9 plus 12.0 plus 12.8 plus 13.4 plus 14.3 is equal to 75.6. And in step 2, square each value and find the sum, which is equal to 11.2 squared plus 11.9 squared plus 12.0 squared plus 12.8 squared plus 13.4 squared plus 14.3 squared is equal to 958.94. In step 3, substitute in the formulas and solve. We use the shortcut formula for the sample variance. And this is the solution shown, which is we get the sample variance is equal to 1.276. And in standard deviation, the variance is 1.28 rounded, which is standard deviation is equal to the square root of 1.28 is equal to 1.13. Hence, the sample standard deviation is 1.13. Another example. You survey households in your area to find the average rent they are paying. Find the sample variance and standard deviation from the following data: $1,550, $1,700, $900, $850, $1,000, and $950. And these are the steps and solutions in this example. The sum of the values is equal to $6,950. And the sum of the square of each value is equal to $8,727,500. Using the shortcut formula for sample variance, we conclude that the sample variance is equal to $135,416.66. And using the shortcut formula in finding the sample standard deviation, the sample standard deviation is equal to square root of the variance, which is $135,416.67 is equal to $367.99. Hence, the sample standard deviation is 367.99.
Variance and standard deviation for group data. The procedure for finding the variance and standard deviation for group data is similar to that for finding the mean for group data, and it uses the midpoint of each class. So example, we have here miles run per week. Find the variance and the standard deviation for the frequency distribution of the data in example 2 to 7. The data on examples 2 to 7 was given on the chapter 2 that was discussed by the last reporters. The data represent the number of miles that 20 runners run during 1 week. So, we have here a table which contains class, frequency, and midpoint.
So we have to follow the step-by-step solution. First, make a table as shown and find the midpoint of each class. So we have here in column C the midpoints, wherein 8, 13, 18, 23, 28, 33, and 38 are the midpoints. Then step 2, multiply the frequency by the midpoint for each class and place the product in column D. So let's just multiply the frequency and their corresponding midpoint to get the answers for the column D. 1 multiplied by 8 is equals to 8. Then 2 multiplied by 13 is equals to 26. Then multiply the other frequency to their midpoints. Then the last is 2 times 38 is equals to 76. Then step 3, multiply the frequency by the square of the midpoint and place the product in column E. Then 1 times 8 squared is equals to 64. Then 2 times 13 squared is equals to 338, and follow the step. Then the last is 2 multiplied by 38 squared is equals to 2,888.
So step 4. Find the sum of column B, B, and E. The sum of column B is N, and the sum of the column B is summation of frequency multiplied by the midpoint. And the sum of column E is summation of frequency multiplied by midpoint squared. The completed table is shown. So we have to find the sum of the frequency, which represents N, wherein the total of the frequency is equals to 20. And on the column D, it represents the summation of frequency multiplied by midpoint. We have 490. And the sum for column E is equals to 13,310. Step 5. Substitute in the formula and solve for S squared to get the variance. S squared is equals to N, quantity, summation of F, multiplied by the midpoint, squared, then quantity, minus quantity, summation of F, multiplied by the midpoint, quantity, squared, over N, quantity N minus 1, then is equals to 20, quantity 13,310 minus 490 squared over 20, quantity 20 minus 1 is equals to 266,200 minus 240,100 over 20 multiplied by 19 is equals to 26,100 over 380 is equals to 68.7. Then step 6, take the square root to get the standard deviation, where S is equals to square root of 68.7 is equals to 8.3. In the group data, be sure to use the number found in the sum of column B, or in the other words, the sum of the frequencies for N. Do not use the number of classes. The steps for finding the variance and standard deviation for group data are summarized in this procedure table. So, finding the sample variance and standard deviation for group data. Step 1, make a table as shown and find the midpoint of each class. We have here columns A, B, C, D, and E, wherein A is for the class, then B is for the frequencies, then C is the midpoint, then D is frequency multiplied by the midpoint, then E is frequency multiplied the midpoint square. Then step 2, multiply the frequency by the midpoint for each class and place the products in the column D. Then step 3, multiply the frequency by the square of the midpoint and place the products in column E. Step 4, find the sum of column B, D, and E. The sum of column B is N. The sum of the column D is summation of frequency multiplied by the midpoint, and the sum of column E is summation of frequency multiplied the midpoint square. Then step 5, substitute in the formula and solve to get the variance, where S squared is equals to N quantity summation of frequency multiplied by the midpoint squared, then minus summation of frequency multiplied by the midpoint quantity squared over N quantity N minus 1. Then step 6, take the square root to get the standard deviation. Step Summary of measures of variation. So we have here the measure, the definition, and the corresponding symbol. For the measure, we have range, variance, and standard deviation, where a range is the distance between highest value and lowest value, and the corresponding symbol is R. Variance is the average of the squares of the distance that each value is from the mean. We use the symbol sigma squared or the S squared. For standard deviation, it is the square root of the variance, and the corresponding symbol is sigma or S. Uses of the variance and standard deviation. As previously stated, variances and standard deviation can be used to determine the spread of the data. If the variance or standard deviation is large, the data are more dispersed. This information is useful in comparing two or more data sets to determine which is more or most variable. The measures of variance and standard deviation are used to determine the consistency of a variable. For example, in the manufacture of fittings such as nuts and bolts, the variation in the diameters must be small, or the parts will not fit together. The variance and standard deviation are used to determine the number of data values that fall within a specified interval in a distribution. For example, Chebyshev's theorem shows that for any distribution, at least 75% of the data values will fall within two standard deviations of the mean. Chebyshev's theorem will be discussed by the next reporter. Finally, the variance and standard deviation are used quite often in inferential statistics.
The next topic in Chapter 3 is coefficient of variation. Coefficient of variation, denoted by C bar, is the standard deviation divided by the mean. The result is expressed as a percentage. These are the coefficient variation formula for samples and for population, which is C bar is equal to standard deviation over mean multiplied by 100%. Let's try this example, sales of automobiles. The mean of the number of sales of cars over a 3-month period is 87, and the standard deviation is 5. The mean of the commissions is $5,225, and the standard deviation is $773. Compare the variations of the two. This is the table, which is, again, the mean of the sales is 87 and the standard deviation is 5. In commission, the mean is $5,225 and the standard deviation is $773. Solution. The coefficient of variation are, we use this formula, C bar is equal to the standard deviation over mean multiplied by 100%. In sale, is equal to 5/87 multiplied by 100% is equal to 5.7%. In commission is equal to 773/5,225 multiplied by 100%, which is equal to 14.8%. Since the coefficient of variation is larger for commission, the commissions are more variable than the sales. Another example, pages in Women's Fitness magazine. The mean of the number of pages of a sample of Women's Fitness magazine is 132, with a variation of 23. The mean for the number of advertisements of sample of Women's Fitness magazine is 182. With a variance of 62. Compare the variations. This is the table of the sample. The mean of the pages is 133 and the variance is 23. In advertisement, the mean is 182 and the variance is 62. Solution. The coefficients of variation are: using again the formula, C bar is equal to standard deviation all over mean multiplied by 100%. First, in pages. The given is variance, so we need to square root the 23, which is equal to the square root of 23 divided by 132 multiplied by 100% is equal to 3.6%. While in advertisement, which is equal to square root of 62 divided by 182 multiplied by 100% is equal to 4.3%. The number of advertisements is more variable than the number of pages, since the coefficient of variation is larger for advertisements.
Range rule of thumb. The range can be used to approximate the standard deviation. The approximation is called the range rule of thumb. It is a rough estimate of the standard deviation is S is approximately equal to range over 4. If the range is divided by 4, an approximate value for the standard deviation is obtained. For example, the standard deviation for the dataset 5, 8, 8, 9, 10, 12, and 13 is 2.7, and the range is 13 minus 5 is equals to 8. The range rule of thumb is S is approximately equal to 2. The range rule of thumb in this case underestimates the standard deviation somewhat. However, it is in the ballpark. A note of caution. The range rule of thumb is only an approximation and should be used when the distribution of data values is unimodal and roughly symmetric.
The range rule of thumb can be used to estimate the largest and smallest data values of a dataset. The smallest data value will be approximately 2 standard deviations below the mean, and the largest data value will be approximately 2 standard deviations above the mean of the dataset. The mean for the previous dataset is 9.3. Hence, the smallest data value is equals to sample mean minus 2s. So let's just substitute the values. 9.3 minus 2 multiplied by 2.8 is equals to 3.7. That is the smallest data value. On the largest data value, it is equals to sample mean plus 2s, then substitute again. 9.3 plus 2 multiplied by 2.8 is equals to 14.9. That is the largest data value. Notice that the smallest data value was 5 and the largest data value was 13. Again, these are rough approximations. For many data sets, almost all data values will fall within 2 standard deviations of the mean. Better approximations can be obtained by using Chebyshev's theorem and the empirical rule.
The next topic is the Chebyshev's theorem. Chebyshev's theorem, developed by the Russian mathematician Chebyshev in 1821 to 1894, specifies the proportion of the spread in terms of the standard deviation. Chebyshev's theorem, the proportion of values from a data set that will fall within k standard deviation of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. K is not necessarily an integer. This is the illustration. This theorem states that at least 3/4 or 75% of the data values will fall within 2 standard deviations of the mean of the data set. This result is found by substituting k is equal to 2 in this expression. 1 minus 1 over k squared, or 1 minus 1 over 2 squared, is equal to 1 minus 1 over 4 is equal to 3/4, or equal to 75%. For the example in which variable 1 has a mean of 70 and a standard deviation of 1.5, at least 3/4 or 75% of the data values fall between 67 and 73. These values are found by adding 2 standard deviations to the mean and subtracting 2 standard deviations for the mean as shown. 70 plus 2 multiplied by 1.5 is equal to 70 plus 3 is equal to 73. And 72 minus 2 multiplied by 1.5 is equal to 70 minus 3, which is equal to 67. For variable 2, at least 3/4 or 75% of the data values fall between 50 and 90. Again, these values are found by adding and subtracting respectively 2 standard deviations to and from the mean. 70 plus 2 multiplied by 10 is equal to 70 plus 20, which is equal to 90. And 70 minus 2 multiplied by 10 is equal to 70 minus 20 is equal to 50. Furthermore, the theorem states that at least 89 or 88.89% of the data values will fall within 3 standard deviations of the mean. This result is found by letting k equal to 3 and substituting in the expression. 1 minus 1 all over k squared, or 1 minus 1 over 3 squared, is equal to 1 minus 1 over 9 equal to 8 over 9 and equal to 88.89%. For variable 1, at least 89 or 88.89% of the data values fall between 65.5 and 74.5 since 70 plus 3 multiplied by 1.5 is equal to 70 plus 45 is equal to 74.5, and 70 minus 3 multiplied by 1.5 is equal to 70 minus 4.5 is equal to 65.5. For variable 2, at least 89 or 88.89% of the data values fall between 40 and 100. These theorems can be applied to any distribution regardless of its shape. See in this figure. In this example, let's illustrate the application of Chebyshev's theorem. Price of home. The mean price of house in a certain neighborhood is $50,000 and the standard deviation is $10,000. Find the price range for which at least 75% of the houses will sell. This is the solution. Chebyshev's theorem states that 3/4 or 75% of the data values will fall within 2 standard deviations of the mean. Thus, $50,000 plus 2 multiplied by $10,000 is equal to $50,000 plus $20,000 is equal to $70,000. And $50,000 minus 2 multiplied by $10,000 is equal to $50,000 minus $20,000 is equal to $30,000. Hence, at least 75% of all homes sold in the area will have a price range from $30,000 to $70,000. Chebyshev's theorem can be used to find the minimum percentage of data values that will fall between any 2 given values. The procedure is shown in this example. Travel allowances. A survey of local companies found that the mean amount of travel allowance for executives was $0.25 per mile. The standard deviation was $0.02. Using Chebyshev's theorem, find the minimum percentage of the data values that will fall between $0.20 and $0.30. These are the steps and solutions. Step 1. Subtract the mean from the larger value, which is $0.30 minus $0.25 is equal to $0.05. Step 2. Divide the difference by the standard deviation to get K. K is equal to 0.05 over 0.02 is equal to 2.5. And step 3, use Chebyshev's theorem to find the percentage. 1 minus 1 over k squared is equal to 1 minus 1 over 2.5 squared is equal to 1 minus 1 over 6.25 equal to 1 minus 0.16 and equal to 0.84 or 84%. Hence, at least 84% of the data values will fall between $0.20 and $0.30.
The empirical normal rule. The empirical rule, also referred to as the 3 sigma rule or 68, 95, 99.7 rule. It is a statistical rule which states that for a normal distribution, almost all observed data will fall within 3 standard deviations of the mean. In particular, the empirical rule predicts that 68% of the observations falls within the first standard deviation, 95% within the first 2 standard deviations, and 99.7% within the first 3 standard deviations. Chebyshev's theorem applies to any distribution regardless of its shape. However, when a distribution is bell-shaped, or what is called normal, the following statements, which make up the empirical rule, are true. For example, suppose that the scores on a national achievement exam have a mean of 480 and a standard deviation of 90. If these scores are normal distributed, then approximately 68% will fall between 390 and 570, because 480 plus 90 is equals to 570, and 480 minus 90 is equals to 390. And approximately 95% of the scores will fall between 300 and 660. When 480 plus 2 times 90 is equals to 660, and 480 minus 2 times 90 is equals to 300. Approximately 99.7% will fall between 210 and 750. 480 plus 3 multiplied by 90 is equals to 750, and 480 minus 3 times 90 is equals to 210. So on the graph or picture on the screen, it shows that 68% falls on the between 390 and 570. And 95% falls between the 300 and 660, and 99.7% falls between 210 and 750.
Step 1. On an Excel worksheet, enter the data in cells A2 to A7. Enter a label for the variables in cell in each. Equal sign, dir, open close parentheses, A2, colon A7. For the sample standard deviation, enter equal sign, SEDEV, open close parentheses, A2, colon A7. Use the difference between the maximum and the minimum values by entering equal sign MAS, open close parentheses, A2, colon A7, minus MIN, open close parentheses, A2, colon A7. Other statistical functions can be also accessed without typing them into the worksheet directly. Number 1, select the Formulas tab from the toolbar and select the Insert function icon. Select the statistical category for statistical function. Scroll to find the appropriate function and click OK. And that's all for the measures of duration. I hope that you learned something. Again, I am Geraldine Rufino with my partner, Timbang from this Red Math 2A.